Okay, we're live. All right, so this one said to just find the period and amplitude, and it said not to graph it on that first worksheet, but we can just graph it anyway, unless you guys have a problem with that, okay? So what is the amplitude? Remember, amplitude is how high up and down the wave goes. 9/5. It's the number in front, right? It's the vertical stretch. Okay, so the amplitude, whoa, no, I should have, you're right, 9/5, right? If it was negative, would the negative be part of the amplitude? No, why, Laura? That's a separate thing. That's if it's a reflection. Very nice. That's totally a separate thing. Amplitude is like a distance. It's got to be like an absolute value. Does that make sense? So this is 9/5. So in other words, we've got this cosine wave bouncing up and down. And I like to think of the corridor that it bounces up and down in between. How wide is that corridor, you guys? Be careful. 18/5. It's twice as big, right? Because it goes up 9/5 and down 9/5. So it would be 18/5 wide. Does that make sense? And that's a tough one because it's a fraction, so it's not easy to visualize up here. Not as easy. Some of you guys can't, I know for sure. Okay, so the amplitude's 9/5, and the period, how do we do that?
2 pi over negative 3 pi over 2.
Did you guys hear Kyle? He just automatically went into it. See, you guys, most of you in the past had trouble with horizontal stretches, because that's what the period, that's what this thing that's inside means horizontal, right? It's either left or right or stretch or compress. Since it's multiplied, that means it's like a stretch or compression. And before, we had trouble with that, I remember, and I understand that. I think that's a little bit of a hard skill. But now in trig land, it shouldn't be a problem anymore. Figuring out how much these waves are smashed together or not, it's not a big deal. You just say, I know that they start out with 2 pi, and then just divide by whatever's there, and you don't have to think hard. It's very easy in trig land to do that. So if I divide by a fraction, what's that mean? Multiplied by the reciprocal. Pi's cancel in this case, right? Negative 4/3. Now this one would be kind of a pain to graph, but I think we should just try, because then if you can graph this, you can graph anything I gave you. So I can give you about much that's too difficult, I don't think. So, how high up and down are we going to go again?
9/5 positive and 9/5 negative.
Okay, so 9/5 is like how big though?
Almost 2.
We can just label it and just not worry about it, right? But it's almost 2. You guys hear what Kyle said? He said it's almost 2. That's true. You could just be like 9/5. I'm good, you know? Anyway, so it's like somewhere up here. And cosine, does it start up here?
Yep.
Or does it start down, or does it start in the middle? Cosine starts up, right? It starts at the top. Sine starts where?
In the middle.
In the middle. Okay? So like 9/5, something like that. And tangent, what'd you say? Tangent's not a wave. That's a totally different shape. We'll do it next Monday. Okay? Very good question. So this is going to be done. How far is it till the cosine wave is done with one period, one cycle?
Negative 4/3.
And negative, what the heck? Do you guys think I should have included that negative? Just like what Laura said earlier? It doesn't really make a difference, but you know what? Technically, it's not supposed to be in there. Whatever. If you put it in there, it's still 4/3. So this is 4/3, yeah. And then one more period would be how many thirds? If that's 4/3, then this would be like 8/3. No pi, right? Usually there's a pi on these. See, I want to put pi, just like it's my reflex action. Anyway, so it's going to start, let's do it in red. It's going to start up here, go down, etc. So let's just draw that. And does anybody have any questions yet? What am I ignoring? What did I ignore? The negative. I just ignored that, right? What the heck is this? It's a reflection. Which way? Is it negative x or negative y? negative x, which means it's that way, right? This negative means it's flipped to negative y land. You guys probably know that one better. But I'm just going to ignore it. I wonder why I'm going to ignore it.
Cosine, it's gonna stay the same. If it was sine, it would change, but cosine won't.
You guys hearing these brilliant comments in the front of the room? They said since it's cosine, if I continue it over here and I flip it that way, what's going to happen? It's going to be the same, so do I even need to worry about it? But what if it was sine and it started right here?
Well, then it would
You would
change
have to
because it's
Then we would have to like flip the humps, you know what I mean? Flip the troughs and valleys of the wave. Yeah, Christian.
So sine only goes one way.
Yeah, but you just have to draw it to find that out. Would you say sine only goes?
X.
Yeah, but we're not going to memorize that rule or anything. We'll talk more about that as we go. So no memorization here. You just got to draw it and see what happens. Yeah, no memorizing. Okay. Good questions. Really good comments. You guys are great. So let's see. So this one was matching, so you're going to have a bunch of problems like that too. Or some of your problems on the second worksheet are going to say, here's a picture, give us a function for that. So let's just do it that way. You can match it up or whatever, but let's just write down what this is. And what do you guys think? Do you think there's only one answer? We could probably write it down as a sine or a cosine, like scooted over, you know? There's usually one easier way though, so I'd pick the easier way if I was you. So we'll do a couple of these. So cosine, who said that?
Cosine.
Ah, Katie, why'd you say cosine?
Because the hump is on the line.
See, she's looking at this to decide. She said, if I look here, it's starting all the way down, and if it starts up, it's definitely cosine. Easiest to do with cosine. Or if it starts down, how could you do it down with cosine?
It's gonna be negative y.
Negative.
It's going to be negative where?
Y.
Negative y, negative the function. So we'll call this f of x, put the negative on the y.
It's two.
Does that make sense? Are you guys clear with why I'm saying this is negative on the y?
It needs to be.
Because like this negative could be divided over here, and what is f of x? Y. It's the negatives on the y. It's outside too, right? Outside is y. Inside is x. Yes. Okay. So negative cosine. Okay. We need to fix it more though.
Negative 2.
Negative 2.
Oh, it goes down 2 and up 2. So negative 2. Okay. And then inside's always hard to guess. We're not going to shift it left or right, are we?
No.
If you do that, it starts to get tough. But so
Inside's
I'm going to
1/2.
say no.
It's 1/2 inside.
It's 1/2?
Yeah, that one. Oh, yeah.
How the heck is Kyle coming up with that times x, right?
Because you divide that.
Because if
2x
you
divided
flip
by
that-
that. And 2 pi divided by that is 4 pi.
You hear what they're saying? They're thinking hard. They're like guessing and checking and thinking hard, which is awesome. It's an awesome way to do it. But you don't have to think that hard if you don't want to, so it's up to you. I totally don't care. I would probably be guessing and checking if I could, but what's up, Christian?
If the period is just 2 pi over that, which is inside, couldn't it just be 2 pi? And then you flip it once it's divided by that?
Yeah, you're thinking right. So you don't have to guess those, what I'm saying. Just write down exactly what you're saying. Okay, so this is going to be a little bit tricky for some of you, I know. This is the only part that might be tricky, okay? So how do you do it? You just say, well, what do we usually do? We go 2 pi for sine or cosine. It won't be the same for tangent. We go 2 pi and then we divide by, let's just pretend we weren't as clever as Kyle and we just said, you know what, it's just something. I called it b. So divided by b, and what's that supposed to be equal to?
4 pi.
4 pi. Then you look at the picture and you say, okay, what is the period of this guy? You could look from here to here. Does that start and end? That's 4 pi. Or you could look from here to here.
4 pi.
Either way, the period is 4 pi. So you just say make that equal to 4 pi. Because that's how we found the period, right? When we did it the other way. And then just solve your little equation and you don't have to worry so much. So if I want b, what do I have to do? Put it up there, right? Well, it's like the common denominator equations we did. It's just a really easy one. You just say, okay, what's the common denominator? B multiplied on both sides. So then we get 2 pi equals 4 pi b. And we get rid of that 4 pi by dividing. And b is 2 over 4, 1/2. 1/2. That's the wave that we were looking for. Okay? So if you want to try to guess that, by all means do so. But make sure you're right. Okay? You heard what Maggie and Kyle were doing? They were in their head going, okay, 2 pi, they like guessed this, and then they were like 2 pi divided by that. In their head, they were like flipping it and say, oh yeah, that's 4 pi. But that can be a little tricky sometimes. So, yeah, Christian.
On 28, I have a question. Why did you, why is that where it is? Like, so you have, it starts at the y, right? At 9/5. And then how do you decide where to put it down?
See, I'm always using the strategy of 3 points, right? So I start high, you're good with that, you said, because it's cosine, right? And then I just said, okay, at 4/3 I'm going to end. So I'll end in the same spot. And then for cosine, it's going to be all the way down in the middle, and then I just wave it. Does that make sense?
So it's on cosine, it's always going to be in the middle of the 2 points?
Yeah. And then sine is the same kind of way. So let's do one with sine, and we'll do it the same way, okay? So let's do one with sine and review that too. So you guys want to look at that other worksheet and I'll do one? Pick one. See if you can find a nice sine wave that it asks you to graph. We'll just graph it. I don't care, it can be easy or difficult, whatever. There's not very many difficult ones. So. 66. Oh. You guys picked. I don't want to do that.
Why not?
It's a little bit interesting.
Well, then do it together. Share the interest.
Let's do it. So let's do a negative sign. Should we do 59? I like
66. You don't
but
want
it's, I want one that's going to be a little easier for all of us. Because if we couldn't all do 66, that'd be all right. But how about 58? 58, that looks nice and medium to me. There are a couple tough ones on here. Let's do 58, okay? Copy came out a little bad on that one, didn't it? So let's graph that guy, then we'll do one more match, and I think that's probably good, okay? All right, so what happened here? I'm going to go around and call people. Gloria, can you tell me what this -2 does?
Up 2. Right? Did I mess it up again?
Were you going opposite?
Oh, down 2. Okay.
When do we do opposite?
When it's negative on the other side?
When it's negative
X. Okay.
inside.
Oh.
Yeah? Horizontal stuff is opposite. Okay?
Alright.
Good. Good review. Okay, let's see. Mandy, can you tell me what's the 4 do?
Doesn't it move it up? Oh, no.
No,
It has
because
something
that
to
moves
do
it
with
down.
that, kind of.
Okay.
I don't know.
Somebody else tell me? Jerusha? It's
It's
not inside. Junior,
Vertical stretch of 4.
vertical stretch of 4, which we're now calling amplitude. Okay. Ben, can you tell me what amplitude really means?
It's just the corridor that it moves in between, so it would be 2 and -2.
Oh, I
Like
see what
so.
he's doing.
Like
How high
that.
up and down would it go, though?
What do you mean,
Like from wherever this is, it's going to go up 4
Oh, and down 4.
and down 4. The reason that this is weird, you got both these things going on, right? So that's why I picked this one. And then, Christian, can you help me with the period?
Yeah.
What's the period going to be?
So the period's then going to be 4 pi over pi, or just 4 pi.
You guys know, I think he's close. So then you multiply by the reciprocal. But what happened to the pi's? So it's just 4.
Yeah.
Good. Okay. So we need a little work. So you guys need to do your practice. We have the main ideas, but gotta tighten them up a lot. Okay. So let's see. So where should I start graphing this? Always, go ahead. The asymptote thing. I always want to do the vertical shift first. So that was, Gloria said down 2. Okay. We go down 2. And like we said, it's not really an asymptote, but an asymptote is a guide, so whatever, potato, potato. Okay, so from there, we're going to create our corridor like Ben said, right? We're going to create our corridor. Now, how wide is this corridor going to be? It's going to be 8 because we're going to be going up 4 with the amplitude and down 4. Does that make sense? So, all right. And how long is it going to take us to complete a cycle?
4.
Also 4. Crazy. There's lots of 4s here. Coincidence, right?
Only 2 is
So
actually.
4. And then, so how far down are we actually going to reach with our wave? Negative 6. Does that make sense? 2, -2, and 4 more is -6. And how high up?
2.
Up at 2. Okay. All right. Now, Christian, here's the answer to this is what I was building up, the answer to your question. So let's review how to draw the sine wave again. So this is a positive sine wave. Where does sine start? Usually it starts at in the middle, at the origin. But where's our new origin? It's right in the middle of our corridor. Like Ben said, it's now there, yes? So we're going to put it right in the middle. And then you guys tell me, does sine start going up or does it start going down? It starts going up. If it was negative sine, it would start going down.
So then,
Okay.
the number in front of sine is like an asymptote.
This
Or
number?
no.
This just controlled how high up and down it went.
Okay. So
Since it's sine, we put it in the middle. So the middle was here.
oh, it's always the middle.
It's always the middle. That's right, but we had to move our middle, because of the -2. Does that make sense?
Yeah.
Okay, good questions. And let's see, so now where are we going to put our other dots, just like I did with cosine? So where should I put some dots? Any ideas, Brandon? Right here? I think he's saying right here. Maggie, where's the other dot going to go?
Go 1 above the 1, 1, right?
1, 1?
Yeah, because isn't it 2 above the asymptote?
Because you got 4.
But that 2
I just want to go from right here. This is the middle, isn't it? Because we're not quite done yet. The period was 4.
-2.
And then I'm going to put another one right here. Kyle's telling me some good stuff too. So, you guys see what I did though? For cosine, you go high, high, low. For sine, you go middle, middle, middle. Does that make sense? And then you say, okay, you guys said starting up or starting down?
Up.
Starting up. And how high up?
2.
We said go up
It'd be-
4, so it'd be like that.
It'd be about 1.
Uh-huh. Very nice.
That marker's pink.
And then I'm going to go down to -6. So that this is 4 and this is 4. There's the wave. Does that make sense, Christian? So cosine up, up, down. Sine middle, middle, middle. Decide which way you go and you're done. We don't have 2 cycles though, so we better do 1 more. So this is going to be -4. I'll go this way this time. So I'm going to go middle, middle, middle. But should I go up this time?
Down.
I gotta follow the trend, kinda, right? Something like that. Not perfect. Make sure you get some arrows going on there.
And it just goes on.
Goes on forever. It's a wave. Okay? What would the range of this wave? The domain, of course, of all sine and cosine waves, no matter what they are, is infinite. The range depends on the amplitude and stuff, though, right? What's the range?
2 and -6.
-6. 2. Okay? Alright. Let's see. Are there any other kinds of problems on there? Have a look at that worksheet. See if anything else needs me to go over it.
66.
66.
Those little
Let's do number
extra
96.
here, circle this.
I don't know. We'll see. Look at the other side. There's another side. You better make sure. Should we do one of these applications? Oh, and you guys, you know what? You can cross out. Let's see. Cross out 85 through 88. We're not going to talk about average rate of change yet. So you don't have to do 85 through 88. What? Look at 89 through 92. Is that something we've done this year?
Oh, yeah, that's it.
Yeah.
What's that little circle thing mean?
F of G of X.
F of G of X, right? Remember, when you do those problems, you can do those for sure. They're like asking you to plug some things in. What's this guy mean?
F
G of G.
It means put F of 2 into
G.
G. So that's something we've done. Let's do one of these applications. These are great applications. Real world stuff for sure. Alternating current. So this is the electricity that's in your wall and in pretty much all devices that are connected to the power grid. Is alternating current in your phone though? Your phone uses direct current, anything that has a battery. But anything that's connected to the wall is alternating current. Oh, it's a whole long discussion there, so we'll have it in physics, okay? But good question. Okay, so which one should we do? Looks like some of these are just saying what's the amplitude and period of that alternating current wave. That shouldn't be bad, it's the same thing we've been doing. So don't let these scare you. Use Ohm's law. So let's do,
Can we do 96 and 95?
we'll do one of them. Yeah, one of them. Should we, let's do 95, because it's hard to see that one. Okay, let's do 95. Last one for today. 95. Okay, 95 says the voltage produced by an AC generator in time is, it's a function of time, so voltage is 220. This must be Europe, because Europe works on 220 volts, and so does like your dryer. They have a bigger plug. If you ever see what your dryer has, they have like a much bigger voltage capacity. They run on 220. Anyway, it says what's the amplitude and period? We can do that. You guys can tell me that. Give me a sec. Let's see. And then we're supposed to graph it. That's pretty easy. I'm going to leave the graph. Well, we can do that, I guess. And then we need to do a little physics on part C. Pretty easy, but okay. Amplitude and period. Can you tell me what the amplitude and period of this electricity wave are, Jerusha? Okay. The amplitude is 220. That's because when electricity is alternating, it gets up, this one specifically, gets up to a maximum voltage of 220. Is it always 220 though? It's between 220 and negative 220, okay? Because it goes back and forth, it changes direction, it's alternating. Okay, Ben?
And then the period would be 1 over 65, right?
Period, ooh, good stuff. So we go what, 2 pi over this? And you're saying, man, I don't like that number, but this is important stuff. This is the real problem. This is a real problem, yeah? 1 over 60. What does period really mean? Let's go back to that. It means how long it takes a wave to cycle. That means alternating current of this variety cycles once every 1 over 60 seconds. So if you have alternating current that you slow down, if you slow it down, would you be able to see the lights flicker as it changes direction and turns them on and off? Yeah. But the lights that we're running here, they actually also cycle. They're on 120 volts, but they also cycle at this. They have this same number in there. And they cycle so fast. Can your eye see that? When it does it once every 1 over 60 seconds, that's really small, really fast, right? That's why you can't see them flicker. There's more to it than that too. But anyway.
Is that why sometimes I...
Okay, so what else? Graph it. Do we need to graph it? Can you guys graph that? Should we just do sketch? Let's do sketch. Goes up and down 220. We'll just say 220, negative 220. So if we made like this 60, would this guy be bouncing and oscillating a whole bunch, or would it be just bouncing really slowly?
Lots.
It would be bouncing.
Lots, right? It would go like this. Sine starts in the middle, right, Christian?
And it would go 60 times.
And you'd go like... This is what electricity does. So how many times would it cycle between 0 and 60 seconds?
No,
One.
And I made this like this would be 1 second, right? So this is like, I don't want to get into units too much, but this is like 1 second.
So then it
So it's like 60 hundredths. Whatever.
It was 60 seconds.
Okay, so if it was 60 seconds, then
Then it would be like.
my point is it bounces a whole bunch. Okay, let's not get into it too much.
3,600 times.
Okay, part C,
Was it about as much as I scribbling?
probably. What else? Part C. Okay, it says like the wire that you have has a certain resistance. What did they say was the resistance of our wire that this electricity is in? 10 what? Ohms. Cool. Resistance is measured in ohms. Here's the symbol for ohms. And it says, what are we supposed to do? What is the current? And they give you a little law from physics, really, really simple little law called Ohm's law. Have you guys heard of that? Does Mr. Hale work with that with you guys?
We didn't do very many laws.
We did mostly like.
It's okay. Ohm's law is just voltage equals what's I? Current times what's R? They just told you that's resistance, okay? So, if we wanted to solve for I, they just said put in 10 for R, right? And then what's our voltage? Do we have a number for it?
220.
Well, that sometimes it's 220. It's this whole function, isn't it? So we can put that whole function in over there. Oh my gosh, I'm running out of room. We had R and we had I. So if I want I, how am I going to solve for I? Divide by 10. So if I divide by 10, what's I going to be? 220 divided by 10 is 22. So then what's the last part of the problem? What does it say? What is the amplitude and period of this? Well, what's the amplitude?
22.
22, and what's the period? Same 1 over 60. Yeah. So this is what the current is. And it says graph it. Oh, you know, you guys can graph it. It'd be the same thing as this, except what would be different? It'd be like this, right? So don't let those little problems at the end intimidate you guys. They're pretty easy. Nice little intro to a bit of physics.